meter per second, velocity is meter per second. So meter per second square, right? All right. With aspects. So there was few numericals on acceleration. Did we do them? Did we do this? When did you say what is in uniform expression, non-uniform expression? We did that?
Yes, sir.
Then Rahul pedals. Before that, Rahul pedals a bicycle. Had I given you a homework? Homework दिया था?
So kilometer per hour को मीटर पर सेकंड में कर देते हैं.
जिसमें
वॉल्यूम की क्वेश्चन.
कौन सा वॉल्यूम में क्वेश्चन करता हूँ? टेक्स्ट बुक देखा क्या तुमने जाके? टेक्स्ट बुक में देखो पेज नंबर 103. 103. Point with sex. Yes, 103. Now this second question. So in the volume, it might be on page 164. 165. Which question is that? Volume में page 165, 10th question. So how much answer did you get? Minus 1.44 into 10 raised to 4 kilometer per hour square. That is correct. Did you find it in seconds? That was the question, right? How many of you found in seconds? Let's find it in meter per second square. Okay. So we got the answer as minus 1.44. This is question number 10. Page 165 of your volume. Those you got volume. And for textbook, in textbook, it is on page 103 of old NCERT book. I don't know how many of you have old and new. All of you have old book? Is it 103? 103? This is the second question. I think what is the page number? 77. Okay, so new book is page 77. Okay, so now you check. So we have done till here. We found the acceleration to be minus 1.44 into 10 raised to 4 kilometer per hour square. Right. This is what we want out. So how do you convert it in meter per second square? Pi by 80. That will be for meter per second. So you want meter per second squared. If it was just kilometer per hour, then you can do pi by 80. So here you will go like this. Kilometer is 1000 meter. Hour is hour into hour. So 3600 second into 3600 second. Got it? This is what you will do. Okay? Because hour is squared. So 1 hour is 3600 second. So hour into hour is 3600 second into 3600 second in the denominator. Okay? So then how will you do? What all the zeros? And one more zero will be cut here. Okay? So this will be 10 raised to 3. Right? 1, 2, 3, 4. So 3 zeros here and 1 zero here. So 10 raised to 2. Now what it is? Minus 144 into 10 divided by 36 into 36. This can be written as what it? 2 decibel absorbed here. 2 decimal point absorbed by 100. What remains is 10. So what is 144? 12 into 12, right?
Yes.
What do you get now? 12 3s are 36. This is how you should simplify and do calculation. So this is 10 by 9 meter per second square. So I find out how much is this? 9 ones are. So this will all be minus. Minus. How much is this? 9 ones are 9. Then 1. Again 10. 1.11 meter per second. So is that correct? Is the volume? Is the answer given in the volume?
No.
Huh? So it's not given. In volume, what answer is given? This answer? Okay. So this is how you can convert it into meter per second square. Got it? So in physics numerical, mostly mistakes happen in conversion of units. So it's not that difficult. With some practice, it will become very easy. Okay, next. Read the next question. Here's nursery question 11 in your UT volume. What is the question?
The train started from a railway station and moving with uniform acceleration against the speed 40 km per hour in 10 minutes. Find its acceleration.
So tell me, what is the initial velocity of the train? Why? Because it is starting from the station, right? So given u is equal to 0 km per hour, and then it attains a speed of 40 km per hour. Now, how much time?
10 minutes.
10 minutes. That is 60 into 10, 600 seconds. Okay? So it is 600 seconds.
So by conversion, it is in kilometer per hour. Why do you have to convert?
So then in hours you have to convert, not in seconds. So I can write this as 40 into 5 by 18 per person. Okay, then this I can write 600 seconds. Either ways. Or you can divide this by 60. Okay, what do you want to do? So both ways we can try. Or 10 divided by 60 R. Correct? So whatever answer you want. So in kilometer per hour square, because we want to find out acceleration. V minus u by t. So here V is, let's say, kilometer per hour. So it is 40 minus 0 over kilometer per hour. Time in R is 10 by 60 is 1 by 6. 1 by 6. How much is this? 6 into 40. This is R. When it goes up, it will be kilometer per hour square. 240 kilometer per hour square. Okay, this is the answer in kilometer per hour square. And in kilometer per second, A is equal to, what is V now? 40 into 5 into 5 by 80. Okay, divided by 600. This whole thing will be in meter per second square. So how much is this? So 40 into 5 divided by 600 into 80. Now solve this. So 4, 4, 4. So this is 1 upon 3 into 18. How much is this? 1 upon 3 into 18? This 54, which is 1 upon 54. How much is 1 divided by 54? 0.0185 meter per second square. Is this the answer? 0.0185 meter per second square. So the thing is, it depends how the question is asked. Okay, if the answer is asked in meter per second square, then you have to follow this. You have to convert it like this, right? What you have to convert? Time given is in minutes, so that has to be converted in second. But you can also find by converting time into hours. That time you have to divide it by 60. So it's mathematics. Any questions, anyone? This is our fourth lecture or fifth lecture for this topic, for this chapter. Huh? Fifth lecture. Are you writing a date and sixth to start here, na? Sixth to start here. Sixth is Thursday, right? Started on 6th. Wait a minute. So we have taken 1, 2, 3, 4. This is the fourth lecture. We have 2 more lectures to finish this chapter. So, alright. Now we will be starting the graphical representation of motion. So graphical representation of everybody is familiar with graph. Now you know that it has x and y axis, right? So on the x-axis, you put the independent variable. So on the y-axis, you have dependent variable. You know what is independent and dependent? Independent is something which changes on its own, like time. It will go on increasing. Okay? Then with time, how the displacement or distance is changing. Okay? So therefore, we have different types of graphs, such as distance or displacement. Anything. Okay? Distance or displacement versus time. Graph. This is the first type of graph. Meaning how the distance is changing with time, or how the displacement is changing with time. So distance will be kept on y-axis, and time will be on x-axis. Okay. So let us say I draw this graph, right? So my distance is here. So distance is in meter, and time is in seconds. Okay. So this is my origin. Let's say 1, 2, 3, 4, 5, 6, 7. Right? Let's call this as 5, 10, 20 like that. 5, 10, 20. Right? Let's say in 1 second, the object moves 5 meters. So what is the point now? This is the point, right? In 2 seconds it reaches or it covers 10 meters. So this is the point. 3 it covers 15 meters. This is the point. So in equal interval of time, it is covering equal distances. Like in 1, 5, 1 and 2, another 5, 2 and 3, another 5, right? So this is this type of motion when equal distance is called uniform motion, right? Another 1 second it covers another 5. So you see for uniform motion, you get a straight line. Okay? For uniform motion, what do you get? You get a straight line. So whenever you see a distance, it could be displacement also, or displacement versus time graph. Whenever it is a straight line, it indicates uniform motion. Okay? So if it is not a straight line, then non-uniform motion. So non-uniform motion could be anything like, so it could be a curve. Any curve. If it is not a straight line, it is non-uniform. Right? So I would have called it displacement. If the motion is in the same direction, it will be called as or displacement. Okay, this is only when the motion is in the same direction not changing. You have to remember that. So is that clear? Now, there is a concept of slope. Have you heard about slope? Huh? So let's understand what is slope of distance time graph. What is a slope? Slope gives the rate of change of distance with time. Okay? Which means it is given as change in y-axis with respect to change in x-axis. This is the general formula of slope. Okay? Just write slope. So you will study about slope in mathematics. Okay. So what is slope? Change in y-axis versus change in x-axis. So what is x-axis here? Time. And what is x-axis? Distance. What is rate of change of distance? Speed. So therefore slope gives speed. So from the distance time graph, you can calculate speed while finding out the slope of the graph. Now how to find the slope of the graph? Let us say I want you to find out what is the speed of the object between 2 and 4 seconds. Okay. So what you will do is, this is 2 and 4. You draw a parallel line. Okay. This is how you draw. So this gives you the time interval from 2 to 4 seconds. Okay. Now you draw a line on y-axis from this point. One on x-axis, one on y-axis. One on x-axis, one on y-axis. So now what do you get? This is the variation in y-axis. When time was 2 seconds, that time distance was 10. Now when time is 4 seconds, distance is 20. Okay. So what is the change in y-axis? What is change in y-axis? So you can say S2 minus S1 divided by E2 minus E1. The slope of distance time graph. This is the general formula. You can choose any 2 points. Just choose any 2 points. You could have chosen from here to here also. Okay. Now see what you get. For this, you get 20 minus 10 divided by 4 minus 2. So what do you get? 10 minus 10 divided by 2. This is equal to 5. Distance unit is meter, time is second, so it will be meter per second. So slope gives velocity, speed. Okay? Slope of distance time graph gives you speed. So therefore, slope of distance time graph gives speed of the object. Okay? So from a straight line distance time graph, you can say that it is a uniform motion. So its speed has to be constant, isn't it? So now let us find out its speed in any other time interval. Let us say between 1 and 3. So this is the change, variation in distance, and this is the variation in time. Let's find out. So here, so E is equal to, now we know that it is speed, so what it is now? 15 minus 5 divided by 3 minus 1. How much is this? 10 by 2 is equal to 5. Got it? So speed should be constant, so it is verified. Anywhere you take, speed is constant. Clear? If not understanding, ask. I know it could be a little tricky for some, so feel free to ask. So straight line, slope, you know what is slope? Slope is like this. This is plane and this is slope. So the incline is called slope. Now this is some kind of angle. So for this straight line, the slope is same, right? That slope is velocity over here. And that velocity is same throughout if the motion is uniform. You understood? Okay? Now, so here velocity will be different because slope is changing. What is the slope? Slope is generally you draw a tangent. Do you know what is a tangent? So let's say you have a circle. Okay? So circle has this point. Circle also has a radius, right? So at a radius, you draw a line such that radius is perpendicular to it. This line is called a tangent. So at any point on the circumference of the circle, you can have just one tangent, which is making an angle 90 degrees. Got it? So imagine this curve also must be part of some circle. So here you draw a tangent, there will be only one. So this tangent, the slope of the tangent is the slope at this point. Now here you see the slope. Is it same? When you draw the tangent, is the slope same? Here it is like this. So slope is increasing. Slope is inclination with respect to x-axis, and it indicates velocity. So increasing slope means increasing velocity. Okay? So here the velocity is constantly increasing, so it is an accelerated motion. Got it? So this is how it is. So this is not a uniform motion. Right? Similarly, instead of distance, if it was a displacement and time graph, gives what is the slope of displacement time graph? If slope of distance time graph gives you speed, slope of displacement time graph will be rate of change of displacement, which is velocity. Very good. Velocity of the. Got it? So, if you want, you can write this, or else I'll go to the next one. Let me give you one more graph and tell me what is happening here. What is the slope in this case?
Zero.
Huh?
Zero.
Zero, because there is no angle, so it is zero. So what is the speed or velocity? Slope zero means speed zero or velocity zero, which means what? Time is increasing, but is there any variation in displacement? No. So this graph tells you about what is the nature of motion. What is the nature of motion? Body is moving or is at rest? Body is at rest. This kind of questions will be asked. Will be asked, draw the displacement time graph of a body which is at rest. So you have to draw this kind of a graph. Draw the graph of a body, displacement time graph of a body which is undergoing non-uniform motion. Then you draw this graph. Uniform motion, this graph. Okay? This is how. So this is the body in non-uniform. S is distance or displacement, T is time. This is body at rest. Okay, so quickly write it so that So what is the definition of non-uniform motion? Unequal distances covered in equal interval of time. So you can see that from here to here, very little distance is covered. So how to find out? This time, only this much distance was covered, right? From here to here. Right? But if you look at this one, this time, what is the distance covered? Is the distance covered same? No, right? For the first time interval, distance covered is only this much. For the second time interval, from here to here, distance covered is this much. This is more. As the time interval, for the next time interval, distance covered is even more. Right? So it is a non-uniform. Okay. Done writing? Can I erase this part? Next is velocity time graph.
So,
Yes.
if in velocity, we have to show the uniform motion, then we have to draw parallel lines. Then how can we record it?
If in velocity you have to show uniform motion.
See, in 7.
Velocity is constant now in uniform motion. So see, so second is, I have not yet covered that. I have yet to discuss that. So that is velocity time graph. Okay. So velocity time graph means what is changing? Velocity is changing with time. So v will be on y-axis, time will be on x-axis. Okay. So in a uniform motion, what happens to the velocity? Velocity is constant. Like in uniform motion, the slope was constant, whichever time interval you select. Right? So if velocity is constant, then you must get a straight line. Time is changing, but velocity is not changing.
So the same case in the distance.
No. For distance time graph, uniform motion is this straight line.
No, the rest.
That is at rest, there is no motion.
That's what I'm asking.
What are you asking? When there is no motion, then there is velocity. Listen, you did not understand. Here the meaning is the distance is not changing. There is no change in distance with time. This is what is the meaning. Here it is, distance is changing equally in equal interval of time. And this also is the same thing. Velocity is not changing. But what is changing? Distance is changing equally in equal interval. So these two graphs are equivalent. Understood? This is what you have to think. What is changing, what is not changing. When distance is changing, so rate of change of distance or displacement is velocity. Where here, what is the velocity in this case? What is the velocity in this case? 0. Is velocity 0 here? No, it is having some value, but it is constant. Is the body moving here?
It's moving.
Body is not moving here, is it? And here?
There it is not.
Here it is moving, is it?
No.
Yeah, okay, ऐसा कर रहा है कि ऐसा कर रहा है.
The velocity when it is not.
This is distance, right? Is it changing with change in time? तो velocity zero है. यहाँ पे क्या हो रहा है? With change in time, is there change in velocity? No, but is there change in distance? Yes, because this is how it is. समझ आया? ये दोनों ग्राफ सेम है, depending upon what is varying with what. So this is uniform motion. Is the difference clear? So uniform motion can be represented with the help of distance time graph, displacement time graph, or velocity time. Okay. Now, second is velocity time graph. Mein there are four things. I am erasing it. So for a uniformly accelerated motion, now we'll see the velocity time graph for uniformly accelerated motion. Uniformly accelerated means what? What is constant in this case? Acceleration is constant. Means velocity is changing constantly. Velocity is increasing by equal amount in equal interval of time. So you should get a graph like this then. Straight line. So slope of velocity, let us choose any 2 points. What is the slope here? Right? How to find the slope? Now let's call this as T2, this as T1, this as T1, and this as T2. Okay? So the slope here gives change in y-axis V2 minus V1 upon T2 minus T1. Change in velocity upon change in time is is what? Are you familiar with this kind of a change? Change in velocity with time. Rate of change of velocity is what is rate of change of velocity? Acceleration. Okay. So this graph shows that slope of velocity time graph is acceleration. Change in velocity upon time interval. All that we learned, we are not doing it graphically. So graphically it gives you some feel. Okay, it is easy to understand the motion or study motion graphically. Because just with the help of one graph, you calculate anything. Okay, so from velocity time graph, you can find out the acceleration by finding the slope of the curve. And for finding the slope, you just need 2 things, 2 points. So this will give you, this is your V2 minus V1, isn't it? The difference between this point and this point is V2 minus V1. From where you get it? From the y-axis. And what is this? T2 minus T1, the time interval. So in this much time interval, this is the change in velocity. Got it? Change in x-axis, you get this change in y-axis. Got it? So if you know graphs, you should understand it. Have you done studied graphs? So how to get a point on x-axis and corresponding point on y-axis, you know that, right? So at t1, velocity was v1. At t2, velocity was v2. So in the time interval T2 to T1 to T2, that is the difference, T2 minus T1. What is the difference in velocity? T2 minus T1. Okay. Just take this ratio, you get the slope. And this slope is nothing but acceleration. Right? So you kind of conclude it. Slope of velocity time graph gives acceleration. Okay. I say from velocity time graph, we can also find the displacement covered in the given time interval. Right? Area under velocity time graph gives displacement of the object in the given time. Okay. So area of the velocity time graph gives displacement of the object in the given time. So let's say this is 0, 1, 3, 5. Right? So what is the formula for velocity? It is equal to displacement upon time. You know that? Right? Yes. Displacement upon time. So displacement is equal to displacement is S on time. Therefore, S is equal to V into T. Isn't it? Now this is your whatever velocity V, and this is your time. So for this rectangle, area of the rectangle V into T is the displacement. What is V into T? Area of the graph under in this time interval. Okay. So if I ask you what is the displacement in the time interval T1 to T2, so it will be area of this triangle and this full area. Which one? So this is your velocity time graph, right? So I said, what is the formula for velocity? How did we define it? It is displacement over time. Therefore, displacement is equal to velocity into time. Just rearrange. Displacement is equal to velocity into time. Right? So what is velocity into time from this graph? It is the area of this rectangle. Say I wanted to find out what is the displacement covered by the object in 3 seconds. So in 3 seconds, we just draw this line, right, and find the area of this rectangle. So this is time. What is area of rectangle? Length into breadth. So length is time, and breadth is velocity. So length into breadth is area. So V into T is area. Got it? And which is nothing but V into T is nothing but displacement. Right? Okay. Likewise, if I ask you to find the displacement of the body in this time interval, you can choose any time interval, not only from 0, any time interval in between. So then you have to find the area of this trapezium. Area of the trapezium. So what is the area of the trapezium? So it is half sum of the parallel sides. Half sum of the parallel side, which is V1 plus V2 into distance between them, which is T2 minus T1. Right? Area of trapezium is half sum of the parallel sides, right, into distance between them. Or you could have done it in different ways. Or you divide this trapezium into a rectangle and a triangle. So it can be or area of triangle. Let's call it A, B, C, D, and E. So area of triangle ABC plus area of rectangle AC DP. Correct? So what do you get? What is area of triangle ABC? Half base into height. Base is T1, T2 minus T1 into height is B2 minus B1. Right? Plus height is B1 into T2 minus B1. Correct? So if you rearrange, you get the same thing. Will you get the same thing? Half base is T2 minus T1 into height is B2 minus B1. Okay, and is this correct? Chalo, for now you understand that this area, when we take up some numerical with values, you understand this area we have to find out. Full trapezium. Okay. So what have we learned so far? We have learned that slope of velocity time graph gives you acceleration, and the area under the velocity time graph gives the displacement covered by the body in chosen time interval. Okay. Till here, is it clear? Okay, there are some more graphs. Now this is a case of positive acceleration. Positive acceleration, right? Positive acceleration. Why positive acceleration? Because V2 is greater than V1, so this will always be positive. So when V2 is less than V1, that time it will be negative. So what should be the graph then? The graph should be like this. This is a negative slope. Why? Now see, time has to increase always, right? 1, 2, 3, 4. What about this? Let us say this is velocity. The velocity is 10, 15, 20, not 10, let's call it 5, 10, 15, 20. Now at 1, what is the velocity? 20, right? At 3 seconds, what is the velocity? 10, isn't it? So this is V1 now, and this is V2. So this is T1 and this is T2. So what is velocity in this case? Sorry, what is acceleration in this case? V2 minus V1 upon V2 minus V1. You just find the slope. So will you get negative? What is V2? V2 is 10. What is V1? 20. What is T2? 3. T1 is 1. So what do you get? Minus 10 divided by 2. This is minus 5 meter per second square. So whenever you get a slope like this, then it is a negative slope. Positive slope is always like this. Okay? So I told you this type of a graph. Now if I give you another graph, can I draw it here? Now the graph is something like this. What kind of motion is this? Non-uniformly accelerated motion. Whenever it is velocity versus time, then you use the word acceleration. This is uniformly accelerated motion. This is non-uniform. So because here it is positive acceleration, then negative, then positive, but less positive than this. This is less negative than this. It is, the slope is less in this case. Okay? So this is non-uniformly accelerated. Okay. So next is equation of motion by graphical method. We'll take one more lecture to finish it. There are two more lectures. So how are you feeling till now? Tired, energized? Is it okay? Till now okay? Okay. So let us discuss some questions if we have done writing. Shall we discuss the questions? Go to page 165 UD only. Let's discuss question 12. 11 we discussed last, right? So what is question 12? Read.
What is the nature of the distance time graph for uniform and non-uniform motion of an object?
What is the nature? For uniform motion it is straight line, and for non-uniform motion it is curve. Right. Next.
What can we say about the motion
So
of an object?
others also please feel free to read. Hello, you read. Next question.
What can we say about the motion of an object whose distance time graph is a straight line parallel to the line?
You can discuss it. Yes, anybody knows the answer? What can we say?
It is at rest.
It is at rest. Because distance is not changing when it is parallel to that axis. Chalo, next. You. Third one.
What can you say about the motion of an object with its speed time graph with straight line parallel to the time axis?
Now the speed time graph is parallel to the time axis. So what is constant? What is constant? Speed is not changing, so speed is constant. Read the question again. What can you say?
What can you say about the motion of an object if its speed time graph with straight line parallel to the time?
Yeah. So if the speed is parallel, instead of velocity, let's say I take speed. The speed is parallel to time axis. So is the speed changing with time? Is speed changing with time? Why? Well, this is the speed too. Let us say it was 5, 10, 15, 20, 25. Is speed changing with time? Yes. So what is the speed at 1 second? At 2 seconds? What is the speed at 2 seconds? Still 20, right? What is the speed at 3 seconds? Still 20. Is the speed changing? So when the speed is parallel to time axis, speed is constant. So speed is constant, what kind of motion is it? Uniform motion. So you have to understand, okay? And then once you become familiar, then just by looking at the graph, you'll be able to tell what kind of motion is taking place. Fourth,
What is the quantity which is measured by the area occupied below the velocity time graph?
displacement. Okay? Displacement when it is velocity time graph. Distance when it is speed time graph. See, I think you may get confused little bit between distance and displacement. Okay, but if the motion is taking place in the same direction, it doesn't matter. Both are same. Got it? So that's about it. Next is equations of motion. So there are 3 equations of motion. I'll just write it and we'll end the class today. So how was the class today? Was it too heavy? No, no. So you read also. Go home and revise it. Then it will become clear. And before coming, where? Where? Rectangle. Area. AR is area. Area of rectangle ACDE. ACDE. Is that what you are asking? Oh, it's so. Chalo, ठीक है. So we'll start in the next class. Equations of motion. For that, we will make use of the graph. In the next class, revise it. Okay.
Yes.